Okay, this lesson we're going to classify different types of triangles. So there are a couple of things you want to note here. First, whenever you classify triangles, the first way, or one way to classify them, is by its angles. Okay, so here are the four different types we have. An acute triangle, that means all the angles are acute inside the triangle. So what does acute mean? Again, that means all angles are less than 90 degrees. All right, there's what's called an equiangular triangle. Now, most of us are probably more familiar with equilateral, but equilateral and equiangular are one and the same. We just, different names. Equiangular meaning equal angles. So all the angles are equal. Now, what does that mean altogether? If all the angles are equal, then that means every angle is 60 degrees. And that's something you'll want to remember. Okay. Obtuse triangle has one obtuse angle. So that means there is one angle greater than 90 degrees. And then a right triangle has one right angle, which means there's one angle that is 90 degrees. So those are the different names when you classify it by its angles. But you can also classify triangles by the measure of their sides. Here there are only three. So we have an equilateral, lateral just meaning the side lengths. So equilateral, remember we said that's the same as equiangular. Okay, we just call them different names based on how we're trying to classify it. So equiangular means the angles, equilateral means the sides. So if it is equilateral, it is also equiangular, which means all these angles are equal, which again we said each one would be 60 degrees. Okay. Isosceles, this one's hard to spell. ISOSCELES, and it's isosceles. Isosceles means at least two congruent sides. Now, what's that mean? That means if it's equilateral, it is also isosceles because it has at least two equal sides. But if it's isosceles, does not mean it has to be equilateral because it could have only two equal sides. And I know that's kind of hard to figure out in your brain, but we'll talk about that here in a second. And then scalene means no sides are congruent. There are no sides that are equal to each other. So scalene, you're going to see there are no hash marks here to indicate sides are congruent, or the numbers will all be different. So when you classify triangles, you have to classify it in both ways, angles and sides. So here we're going to look at classify here by angles. So we give us angles names. So we look at triangle ABD. So one thing I do is I try to trace the triangle ABD. So in essence, I'm ignoring this triangle over here. I'm not caring about that one at all. So if I look at ABD, all the angles are 60, which makes it equiangular. Okay, let's go to the next one, BDC. So again, what I'm going to do is I'm going to trace it, BDC. So again, one of the things I can do on the iPad that you guys can't necessarily do, but is I can always like erase stuff, so I would get rid of all this because it doesn't pertain to this problem, and that helped me too. So sometimes for you, you might want to redraw the triangle you're looking at to the side. But if I look at this one, there is one obtuse angle in it. Therefore, it is an obtuse triangle. Okay, let's go down to the next ones where we do it by its sides. Here we have two sides marked equal. Therefore, it is isosceles. This one, no sides are equal, so it is scalene. All right, let's continue on. Okay, it says if K is the midpoint of FH, Okay, so I look at FH, so I'm going to trace it here, FH, K is the midpoint, so K to H is 2.5, that means F to K is also 2.5. All right, classify each triangle in the figure. Equilateral isosceles or scalene, so we're using our side measures, so FGH, I'm going to FGH. Now, when you initially look at it, you may say, oh, that's isosceles because it has 2 equal sides. But in actuality, this is an equilateral as well as isosceles. Remember, we said if it's equilateral, it's also considered isosceles. Now, why is that? Well, if I look right here, if this is 2.5 and that's 2.5, all together right here, that side is a distance of 5. Well, if that one's 5 and that one's 5, and then this one has to be 5 because it's got the little congruent symbol, then all 3 sides are equal. So it's both equilateral and isosceles, and I'm just abbreviating here. Okay, let's do one more here. So I'm going to erase all this except for the 2.5 because I want to keep that information in there from the beginning of the problem. All right, so let's look at FHL. So FHL. So this was 3, this is 7. Remember, all together, this was 5. Those are all different, so that means that one would be scalene. All right, a couple more here. Find x and the measures of the unknown sides. So 2 things, x and the sides. Now, how do we do that? Well, it's based on information. This and this are equal. So how am I going to get x? I'm going to set 3x minus 4 equal to 2x plus 7. Work that out. Subtract 2x. X minus 4 equals 7. Add 4. So then x is 11. So that's x. Then what I have to do, I have to plug it in. So I go back and I plug 11 in. 3 times 11 is 33. Minus 4 would be 29. Go up here and plug it in. 2 times 11 would be 22, plus 7 would be 29. Well, since that's 29, should be because, what did we say at the beginning? Those two were equal, so I better get the same value so we can check whether our x is right or not. All right, what about the next problem? Well, here, all the sides are equal. So it doesn't matter which ones you set equal. You just need to pick 2 of them and set them equal. So in this case, I'm going to do 5x and 6x minus 5. So I got 6x minus 5 equal to 5x. And usually I move the smaller variable, but in this case, I'm going to move the 6x over. So that gives me negative 5 is negative 1x. Divide by negative 1. And that gives me 5 is x. Go back now, plug 5 in. 6 times 5 is 30. 30 minus 5 is 25. 5 times 3 is 15, plus 10 is 25. And 5 times 5 is 25. And that should have happened again because we said all the sides were equal. So hopefully this has been a relatively easy lesson for you in terms of classifying triangles and then how to use their names to find measures.